So in the first part of this video, we're going to be spot welding these parallel groups with nickel strip along there and along the bottom, and then hopefully later on we will get into wiring the parallel groups in series with each other. So for this I'm going to be using a rechargeable spot welder. Now you can get much better spot welders, they're very big but they're also very expensive. So yeah, this basically gives a very short burst of current and allows you to melt or fuse the nickel strip onto the top of the battery. So the reason why we use a spot welder over a traditional soldering iron is that because when 18650 cells are exposed to heat, they store a lot of it and they don't release it very quickly. So we want to minimize the battery's exposure to heat by using a spot welder rather than exposing it to heat long term with a soldering iron. So I will show you a bit more in depth in this explanation. So when you're using a soldering iron to fuse the nickel to the batteries, you expose the nickel to a large amount of heat for a long amount of time. By the time you've actually managed to put a sufficient amount of solder in the weld on the nickel, you've created a large amount of heat which can be shown on the wood. However, when you use a spot welder, you limit the battery's exposure to heat quite a lot, as it transfers all the energy needed for a very short amount of time, which will give you much less heat put into the battery. So, spot weld these parallel strips. You need a piece of nickel along the top like that. You then set your spot welder to the correct setting and then place one of the prongs on the nickel. Then when you're ready, you find the position of the other one, press it down, the buzzer rings and you'll make a small weld. You want to do this about 2 or 3 times on each cell, like so. My spot welder handles are way too hot to keep going, but yeah, this just needs to be done. Okay, so finish that off, and I completed the other side the same way, and now I just have to do that 13 or 12 more times. So, time for a time lapse. Okay, now that we've welded both sides of every parallel group, we can now move on to welding them in series. So the first thing that we're going to do is hot glue these cells together. You can do it in this orientation, but for what I'm doing, they need to be like this, as when they are like this, they're just a tiny bit too wide, but this sort of thing fits perfectly. So I just need to line up the cells, hot glue them together, and then we can move on to spot welding. So now that we've glued all the cells together, we can start to spot weld the nickel across the parallel branches in series to start bringing up the voltage. So obviously at this point you want to probably put some gloves on and take off any jewellery you're wearing to prevent any conduction. Okay, to start making these series connections, you'll need a piece of nickel about the length of one of the branches. You then, like before, how we joined the parallel rows, use a spot welder to make a small weld.
Let's go have some fun.
Okay, not the best weld, but as long as it holds on, that's all that matters really. Right, and then we will repeat this all the way down the row, and then do this row underneath, and this row on top, and this row underneath, so on until we've done the entire battery cell. So now that we've wired the parallel groups in series and left one out on the end, as you can see here, we can now turn over the battery and start wiring these ones that have the gap in the middle together. So you probably want to put something down that is definitely not conductive. So I've got this cutting mat, and also you want to make sure that there's no nickel on the table or any metal that can short any batteries and then cause an explosion, which we don't want. So now we can turn this over, and now we can see that we want to leave out the negative end, seeing as the positive end is underneath here. So we can start wiring these, and these together, and this will be left out or connected underneath like that. So they'll be all connected like this in one big chain. Okay, so once I've done that, I'll get back to you and we can probably move on to wiring the BMS. So now that we've wired the parallel groups in series on both the top and the bottom, we should be able to check the voltage, and hopefully it'll be around 48, which will mean that we've all done it correctly. Might be a bit less as the batteries are probably a bit discharged, but this is the moment of truth. And yep, 47 volts. So means that we've done everything correctly so far, and now we can move on to wiring the BMS. So now we're ready to go and wire the BMS in. So on the BMS there is a B- wire, a P- and a C- wire. One of them goes onto all the negative cells, one goes onto the discharge cable, and one goes onto the charging cable. ebikeschool.com has done a good video on wiring the BMS, which is much more in depth than what I can go into, so I'll put the link to that in the description so you can understand how that actually works, but for now I'll just be showing you how I actually put it on. So first we're just going to hot glue the BMS to the side of the battery. First thing that you want to do when you've glued your BMS to the battery is solder the B- wire down the end of the negative side of the battery. So you want to make sure that you solder in between the batteries to minimise how much heat that you're actually putting into the batteries directly. So yeah, once that's done, then we can move on to doing the P- and the C- wires. Okay, so now that we have the B- wire connected, we can connect the other two wires to the discharge and the charging lead. Okay, so now that the BMS is wired to the negative side of the XT90 connector and the red wire is connected to the positive side of the XT90 connector, we can now take this and solder it onto the positive end of the battery, like what we did before with the negative end and the B- wire. Okay, so now we have the charging connector connected to the BMS with the negative wire and the positive wire going down to the positive row of cells at the bottom. So that's been soldered across, and now the charge wire has also been connected negatively to the BMS and connected positively to the bottom row of cells. So now the next thing to do is, I'm pretty sure these are called balance wires, solder all the red ones onto the positive groups, and this goes onto the negative group, the one black wire. Once that's done, we can cover it in heat shrink, and then we'll be good to go pretty much. Now we have all the balance wires wired up to the battery. So on this one there are 14 wires. This is a 13S BMS, so it should have 13 wires, but some of them, like the ones from Drew's end, have got one extra, which is a black one, which goes to the negative terminal here. So now what you basically do is you take the wire 1 to this positive end, wire 2 to this positive end, wire 3 to here, wire 4 to there, etc., until you've gone all the way down the battery pack. And that basically just allows the BMS to keep all the batteries at the same voltage, balance them, and ultimately basically just turn one or a massive group of batteries into one massive battery. So I have tested the voltage working 48 volts. So the next thing to do is add some Kapton tape around, which is this insulative, non-conductive tape, which is obviously what you want from a battery pack. So I'm just going to tape down all these wires, get it all neatened up a bit, and then we'll add this heat shrink around it to obviously protect the battery even more and make it a bit waterproof and stuff. So yes, I'll take a quick time lapse of me doing that, and then we should be almost about finished. And I've put a lot of Kapton tape on, but honestly the last thing I want happening is the battery shorting. So now I'm going to just cover it in the heat shrink, and then we should be about ready to give this a test, which I will do in a different video, but this video is just a tutorial on how to build it. So yes, let's just put the heat shrink on. Okay, the battery is now completely done. I'll probably add another piece of heat shrink just over the top here to cover it a bit. But yeah, completely finished now. Running at 48 volts is the discharge, the charge, and yeah, that's about it. So that's everything you need to know about how to build a battery pack out of 18650s. So that's about it. Thanks for watching, and I'll see you in the next one.